Hello there, ladies and gentlemen, and welcome to another video. Now in this one I'm going to be showing you guys how I managed to write some code to password protect my keyboard. So I'll show you what this kind of looks like. So I'm just gonna turn off the lights here, and the keyboard will like auto lock after 5 minutes by default, or you can just auto lock it yourself with the key press here. As you can see right now, the keyboard is locked, the lights are off, and if I like try and do anything, you know, nothing happens, nothing shows up on screen. And this because right now, in order to be able to use my keyboard, I need to type in a password into said keyboard. So the password is arch. So as you can see here, the more kind of correct letters I type, the more LEDs light up. So as you can see, A, R, and then if I press the wrong button or the wrong whatever, it resets. And after I type in the full password, I can type in again. So obviously you can disable this feature here where it lights up the buttons, because it'll be easy enough for other people to figure out. So yeah, I'll show you how to do that in the firmware later on. And so yeah, the keyboard basically like blocks any kind of like output to the operating system. So this isn't like, you know, done in a program that's running on the operating system. This is actually locking the keyboard in the actual keyboard firmware. So yeah, it's pretty cool, like. And I'll show you guys how to set it up. And I'll also, in this video, do like a nice bypass. So, because at the moment the keyboard will lock like when you power it on. So if I, for example, if I unplug the keyboard and then I plug it back in, it'll be off, so I can't do anything. So you need to type in the password as well when you're like, when you plugged in the keyboard, like so. So what I want to do is I want to add a bypass for it as well, so that after 5 minutes, it doesn't like, you know, lock. I know it's kind of like a cool feature, but it can get kind of annoying, especially if you have a long password. I obviously have like, you know, a different password that I use. I just, you know, changed it to Arch for demonstration purposes. But yeah, anyway, let's hit the code. Oh yeah, and so yeah, like this is gonna be in the video description that you can reference. The initial commit that I did is here. So if I just go into here, so if you wanna implement this feature like yourself, here's the actual like commit that I did. So yeah, because I also use combos, I had to add the RGB. So how this works is, I have this RGB timed out thing that I wrote ages ago. So like the lights on the keyboard themselves will turn off after 5 minutes or whatever you set it to. And I also set it so that it locks as well after, like it just basically uses the same variable is what I mean. So this is why you'll see like RGB timed out everywhere in this commit, because I'm kind of hooking into that, because you know, if your keyboard is locked, you might as well just hook it up to the RGB, because it's a nice, you know, visual indicator that it's locked. So yeah, this is just kind of refactoring the code or moving the code a little bit. Don't worry about that. Don't worry about that as well, that I was just adding in the extra kind of caps feature that QMK has. Don't worry about this as well. The only thing I added here was I allowed the timeout to be greater than 1 minute. This is because I was using a 16-bit variable for the timer counter before, which only allowed to go up to like 2 minutes or something like that. So I increased that variable to 32-bit, and so I can probably go like up to 30 minutes, so that should probably be fine with a 32-bit variable. But yeah, so I brought in back the 5 and 10 minutes. Here's the leader key section. So here is how I basically lock the keyboard. You just set the RGB timed out to true, and that will essentially lock the keyboard pretty much. And here you can see I changed the timer value to 32-bit. This by default reads 16-bit value, so that wasn't enough. And here I'm using as well timer elapsed 32-bit, and this is where like it actually times out after 5 minutes or so, like so. And then same thing here, and this unlock password index. This just basically tracks the current. If you press like letter A, it will change to 1. If you press R, it'll change to 2. If you press a wrong letter like C, it'll change to 0. And so here is the logic for this. This is inside the process record user. So this just kind of like takes in any kind of key codes, and you can manipulate, you can change the key codes, you can do whatever you want with this. And so this is normally meant to be to process macros, because macros are like custom key codes. So as you can see an example here where I set the RGB time value to 5 minutes and 10 minutes here. But you can also use this for like cool features like this. Before I also had like some kind of a word counting feature, but I got rid of that because I wasn't really using it that much. And so yeah, this if statement basically just checks if the RGB has been timed out, and if basically the password hasn't been entered fully. And if your password has been entered fully, then it'll reset everything. It'll reset the timed out to false and the counter and everything. And so you'll just keep on going. But if that's not the case, it checks if the key is pressed, because this can also be released. And we just want to check the event kind of once. We don't want to check if you like released key A, for example. We just want to check it once. And so it checks if the key code that we get into this function is the same as the current key code that we're tracking in our password array. So the password array is hidden because like it's hidden from Git, so you won't find it in this repo. This is because, you know, you don't want to include your password in the open source code. So if we head over to the code here, let me just increase this a little bit and increase the size as well so that you can see. So if you go into sharedDefines folder or file, you will see that have some kind of notes for the custom password. So you'll need to create a secrets.h file and a secrets.c file, and the firmware won't actually compile if you don't do this. So you actually do need to create this, regardless whether you're using this feature or not. Well, with the current setup of my firmware anyway. So yeah, the secrets looks like this. So you basically have an unlock password array, which is of length, unlock password length, which is in the secrets.h. So here it's just defined, so 4, because arch is 4 letters. And so here you have A, R, C, H. So just an array like this. And to get these values, what you would do is you would find them in here. So I have the link here, and I'll actually put this in the YouTube description. So I'll add it here. So it'll be HID key codes for password, and that'll be here. Let me just. All right, so yeah, that looks good. So yeah, once we go here, you'll see that A is 04, R is 015, and C is 06, and so that corresponds with what we have in the secrets.c file, like so. So that's how you do, so that's how that works anyway. And so it just, the for loop here, or the if statement here just kind of tracks if the key code matches whatever you put in, and if it does, it increases the index. And so the next time you send another keyboard or another key code, it will check this again, and it will check with the, you know, with the next index. And if you type it anything wrong after an amount, it'll reset the index to 0, and so you'll keep on going into this if statement because this RGB timed out value is false, or I mean true. So yeah, and also if you want to, if you're testing this on your key map, I recommend you uncomment this and uncomment this. Now what this does is it will only block the letter keys. So from 4 to 39 is, you know, the letter keys A to Z, and also the numbers at the top. Why this is handy is because if you're using key code to put your keyboard into flashing mode, so to flash the firmware, it will actually block that key code as well. So this way, if you uncomment this, it'll only block the letter keys, and you'll still be able to flash your keyboard. Now, you can flash your keyboard anyway if you press, you know, the reset button on your keyboard's motherboard, or whatever that's called. So this obviously won't block it, but in my case, that reset button is actually like hidden under the case. I'll just show you in the cam here. Let me turn on the light. So normally my keyboard reset pin would be located here, but as you can see, it's like blocked by this decoration. So I can't press it to reset the keyboard, which is, you know, pretty good. It will allow kind of more security in this kind of sense. So if someone even knows what key you use to reset your firmware, they won't be able to do it unless they like physically press the reset button on the actual keyboard instead of on the actual board instead of the like key code in QMK firmware. So yeah, that's how that works anyway. And so if we go down, yeah, so here's the kind of LED controller. So yeah, I set the default to 5 minutes because it was locking it after 30 seconds, which was kind of annoying. So this is why I'm going to write this bypass feature in this video as well, because that way I can have the RGB time out after 30 seconds, but not actually lock the keyboard, unless we want to, of course. But yeah. So yeah, this password LED sequence is basically the position of the LEDs on the keyboard. So let me just show the keyboard once again. So like this 47, this is position of this key here. 46 is position of this, 45 is position of this, 44 is position of this, 20 is position of this, 21 is position of this, and so on. So it just kind of goes across the bottom row. So that's what you see. Let me just turn off the lights and lock the keyboard. So that's what you see when I type in the correct password. So A will turn on this, R turn on this one, C turn on this one, and then H will, well, it will turn on this one, but also turn on everything else since the keyboard's now unlocked. So yeah, this also means that your your password at the moment cannot be longer than 9. So just watch out for this, because you will probably end up resetting your firmware if your password is longer, because it'll go out of bounds in the loop later on. So if your password is longer than 9, you need to add some more elements to this array. So for example, if I just go back to here, so you can also add like this row, the next one, or just disable the feature altogether if your password is longer than 9. So yeah, I'll show you actually right now how to disable this feature. Probably should have did that at the start, but whatever. So anyway, if you go into sharedDefines.h, and if you go into here, yeah, so here, if you just simply comment this out, what this will do, yeah, so you should see this will no longer be compiled. So this code literally will not be compiled. However, this code will be compiled. So it'll just set everything to false or everything to off if the RGB is timed out. Whereas before it would, it would check based on the unlock sequence. So that's what I recommend doing anyway, regardless if your password is long or not. And I'll show you how that works now. So I'll just compile the firmware here. So I have a macro set up that literally types this out. So it's kind of handy. I have the, where is it? Yeah, so I have this teensy already running. So my keyboard's like ready for flashing, and the firmware is compiled. So let me just bring this here. And so if I flash the firmware, all right, firmware is flashed now. Yeah, I'm not sure if you saw that, but let me just flash it again. So yeah, you should see like a small kind of box on the screen. I don't know why I was pointing at the monitor. But yeah, so now the firmware is flashed, and take a look at the LEDs that were here before. So if I type ARC, as you can see, nothing, no LEDs, no nothing, keyboard is completely useless, can't do anything. So let me just type that, and then boom, and now I can do whatever I want. So that's how that works. But in my case, I am just gonna leave it on because I think it's a kind of cool feature. I wouldn't really call this, super secure anyway, since like someone could just, use a different keyboard. Or if you're using, a laptop, they could just use your laptop keyboard anyway to work away. But I just thought this was a cool feature. Thought this was an interesting feature that I could do. Pretty fun, Sometimes I just like to kind of play around with the firmware. So yeah, I covered all this kind of already. So yeah, this is just because before I had this timeout as kind of a global kind of thing, whereas now it's actually set inside it's used inside the setLayer function here. Whereas before it was, more efficient this way, because yeah, well, it doesn't matter because it didn't like go into this switch at all before, but now it does. So yeah, we won't worry about that. Yeah, never mind about this. It's just like random shite that I was doing. So yeah, anyway, I included the secrets.c in this compiling, so it'll throw an error if you don't have this file basically now. And I also included in the shared defines the header file, so again, it won't compile if you don't include it. So yeah, I used these before, but I didn't use them properly, so now I'm using them properly. And here I just changed it to 32-bit instead of 16. Or 16 bytes instead of, 32 bytes instead of 16 bytes. Yeah. And yeah, so yeah, this thing here was unsigned 8 bits. I changed, or 8 bytes or whatever. I forgot what this is, but I changed it to signed so you can do negative. I'm not actually sure how it worked before because it technically wasn't supposed to, but whatever. What is this? Oh yeah, so this is the notes that I kind of showed you before. And yeah, so yeah, that's kind of how it works now. So yeah, now what I want to do is I want to add a bypass feature, so when the keyboard like actually locks. So in my so let me just move this all the way to left so there's more space. So in my key map, if I go down here, I can set the timeout to 30 seconds, which I will do right now. So right now, this keyboard, if I don't like press anything for 30 seconds, it will turn off the LEDs. So what I want to do is I want to have that functionality to remain, but I don't want to type my password, you know, every 30 seconds that I'm not using the keyboard. But yeah, you know, like if you press a key, it's gonna refresh that timeout, and so you'll need to wait for 30 seconds again, for example. So I'm just gonna put it at the end here. It'll be an extern boolean, since it's just gonna be a true or false value. So extern bool password bypass. So what this will do is you'll still need to type in the password, or after you plug in the keyboard or whatnot. So I'm gonna add it at the, it's gonna be a macro because that's kind of the easiest way to do it, in my opinion. So this will be password bypass, and I am going to add this macro to my key map. It's gonna be inside the macros. It doesn't have to be, but this is where I have like most of my other stuff. So I am going to set it to probably P if I don't have anything here. Yeah, so if you can see that. So yeah, this will be my P key in that macro. So it's right beside the, oh wait, no, that's not the key P, that's the 0 key. This will be the P key, so it's right beside the bunny hop. So I'll just put that in. Unfortunately, that's a bit huge, so I'll need to kind of move these a little bit out of the way. Yeah, actually, fuck it, let's do it that way. Like so. Just kind of, you know, keep them in line. And I will also do it that way. So yeah, that's for the key maps. That's done. So next we'll need to go into macros. Yeah, we'll declare it here because this is the only place they'll be used, I think. So yeah, I'll just add this here. So it'll be bool, and then whatever, I think I just called it password bypass. Is that what I called? Oh, shit. Where was it? Yeah, password bypass. Alright, so that's good. So yeah, that'll be false at the start. And then inside the macros, if I go into here at the end, it'll be case, this whole thing. And then, yeah, so if it's pressed, break, and what I want to do is password bypass, so just toggle it basically. And then, so yeah, that'll be good to go. And here, what I want to do is, so if RGB timed out, if it's false by default, we want to get in here. So yeah, so if it's false, so yeah, if not, password bypass. So that should hopefully work. And then the last thing I want to do is I want to highlight like the blinking. So here I should have a blink count that I use. Yeah, so basically like this here. This is exactly what I want to do. And I just need to get the index of P, which I'll do in a second. So if bypass, password bypass, and I is equal to P. Now for P I have, let's see, just need to check. So Q to P, so P should be 9. This is just some stuff I did before for custom animations. So yeah, it should be 9. I'll just hope and pray that's it. So if P is 9, then what we want to do is we want to basically do the same thing. So take that, and yeah, so basically the same thing. So save that, and so let me compile it. Hopefully there's no mistakes or anything. All right, that looks good. Let me flash him. All right. So right now, I'll still need to type it in. So yeah, let me just kind of pull up the terminal here or whatever, so you guys can see like if it's still working or not. All right, so now if I enable the bypass, as you can see, the P is flashing like so. So it's flashing, you know, kind of the same color as this. So this will let me know that the bypass is active. And so if I lock my keyboard, I think I should still be able to type like so. So that's good. So if I remove the bypass, so as you can see, P is not like blinking, so that means there's no bypass anymore. And if I lock the keyboard and I type, as you can see, perfect. So now that there's no bypass, I cannot do it. So I need to type in the password like so, and now I can type in some stuff. And if I enable the bypass again and lock the keyboard, I can type away just fine. So yeah, that is perfect. That is exactly what I wanted, and it worked nicely. So yeah, that is perfect. I am going to make this commit. So git status, let's see, what did we modify? Yeah, so we modified the key maps, macros, and all that kind of stuff. So yeah, that's all good. So git add, okay, git commit. So this will be add bypass macro, add password bypass macro, so when pressed or when active, you won't need to enter the password when the LEDs turn off. And also locking the, yeah, actually I wonder, because, you know, we're locking it manually. Yeah, that's true. If we're locking it manually, we would want to turn off the bypass. That makes sense to me. Yeah, so that's what I'm gonna do. So because we're locking it manually. Yeah, that makes sense to me. So inside the leader, let's see, where did we set it? L. So yeah, RGB timeout is true, and what we're going to do is password bypass equals false. So if we lock it manually, then you need to enter the password again, because you took initiative to actually lock it. So yeah, that makes sense to me. So that way, if the LEDs turned off after 30 seconds or whatever, you will still you won't need to enter the password if you have bypass enabled. But if you lock it manually, then you do, because yeah, that just makes more sense to me. Because why else would you kind of go to the physical trouble of locking it, so yeah, I'll just test that real quick. So I'm compiling it now, and I'm gonna flash it. All right, so it should be flashed. So I just unlock it right now. All right, so now P is enabled, and if I lock it, I shouldn't be able to use it. Yeah, perfect. So it locks it actually properly. Now I can use it, and as you can see, P is not blinking, so that means the bypass is off. And if I turn it on, there we go, it'll start blinking. So yeah, that's perfect. That's actually much better. So let me just add all again. And let me copy this, because this was actually on the right track. Oops. Come on. Alright, go away. So anyway. So yeah, if locking manually via the leader key, you will still need to enter the password as you took initiative to lock it. Whereas if the RGB times out, you will not need to enter the password. Yes, that makes sense to me. Let's push that. Looking good. I'm just gonna copy this into here, so can be locked manually. So I'll just tidy this up a little bit. What the fuck is this? Oh, I see, copied it twice for some reason. So yeah. In this video, we also add in manually, or fucking password bypass. Oh Jesus. When active, you won't need to enter the password. When the LEDs turn off. If locking manually via the leader key, you will still need to, as you took initiative to lock it. Whereas if the RGB times out, you will, yeah, so that is perfect. That looks good. One thing I will need to is add this commit here. So let's go into here. All right. So it should be the very recent commit. Yeah, there we go. So yeah, there we go. So let's just go through this nicely, just in case I messed something up. Okay, so we enabled the macro here to toggle it. We disabled it here in the leader key. When we lock it, we added the extra variable and we added it to the condition. What is this? Oh yeah, and then we also added the special LED for blinking on the peak when it's active. And we added the macro here and we put it as an external boolean since we defined it in a different function. So yeah, or different C file. Yeah, so yeah, that looks good. Everything makes sense to me. Where's number 4? So yeah, let's just paste it in here. Okay, so yeah, that looks good. So yeah, some good features. Everything is nice. So yeah, thanks for watching, guys. Bye bye.